Okay, this is your first one of the recordings. I will have several throughout the year, not all lessons, but some. Intro to Geometry. This discusses points, lines, and planes. You're going to be given an essential question. This is something I want you to ponder on when you are going through your lesson. Also, please remember anytime you need to stop or pause it so that way you can copy or replay, please do so. So how do you name geometric figures? Well, in geometry, the terms point, line, and plane are known as undefined terms. Now, the reason why they're called undefined terms is because they have no shape. They have no size. We don't really know what they look like. We determine that they look like this, but they really are not. We can't give it a size. Point is 0 dimension, line is 1 dimension, and plane is 2 dimensional, but they're infinite, so we can't measure them. So again, they do not have formal definitions because we can't really describe them, but we agree on what they mean. So as I said, a point has no dimension. Now we label our points as capital letters. Any capital letter in the alphabet. It's usually represented by a small dot. So in this case, it's point A. We would name it point A. A line is 1 dimension because it does extend into 1 dimension. It's usually represented by a straight line with 2 arrowheads to indicate the line extends without end in 2 directions. Now, please understand that the point, when we're putting points next to each other, a whole bunch of them, that's what's creating the line. So this line that's shown here actually has an infinite amount of points. But you usually will see at least 2 points on the line in your textbook or on a test, quiz, etc. Another thing that you might see is a lowercase cursive letter. The lowercase cursive letter is another way to represent a line, only a line. Now these are the 2 different ways of naming the line. The line with the cursive letter L, or notice the AB. Now, let me back up on that. Line AB is naming only 2 points. Even if there's 3 or 4 points on there, you only name it by 2. 2 points. Notice the notation on the top. It looks just like a line. That determines that we are talking about the line that is infinite, line AB. Now, collinear points means that all the points that are on the same line, so in this case, A and B are collinear because they're on the same line. Notice it's got the word line in it. So that's a good way to memorize it because this is a terminology you will have to know. So they coexist, and linear, collinear. Now a plane is the one that extends in 2 dimensions. It's represented by a shape that looks like a table or wall. However, it could be any shape as long as it extends without end. So again, it's extending on and on and on and on and on. So here's some examples. This one here is the most used. But again, it's supposed to go on forever. Now, coplanar points, just like collinear points, are points that lie on the same plane. Okay, so they're all existing on the same plane. Remember, a plane has no thickness. Okay, it's only 2-dimensional. So I could have a point above it, but not beyond it, or a point below it, but not beyond it. If I see any point beside it, which usually they don't draw that in your textbooks or quizzes or anything like that, because again, the plane is infinite. So they usually put the point above or below to represent that it's not on it. So here you have 3 points. Notice these 3 points are not collinear. They're not on the same line. In fact, you can draw a triangle to make them, into a triangle. You can connect the points, A, B, and C. And if you connect the points A, B, and C, it creates a triangle. That's a way you know that they're not collinear. That is the way you can name a plane. You can name the plane by 3 or more points, but they must be non-collinear. Now, you could have 2 of them collinear as long as the third one's not. Also, another way to name the plane is a capital letter in any corner. Notice that there's no point next to that because it's not a point. It's just representing a plane. So this is either plane M or plane ABC. And now notice, again, it has to be 3 or more letters. Now, the point, first let's go to the point, only had 1 letter. The line had 2 letters. The plane has 3 or more. So that's a good thing to remember. The reason why you cannot just name it by 2 is if you have a line, that means there's a whole bunch of infinite planes passing through that line. So we don't know which one you're talking about, and we'll look at that more later. All planes, as I said, are formed by 3 nonlinear points. Oh, my highlighter got off there a little bit. In geometry, terms that can be described using known words, such as point or line, are called defined terms. Now, this is where we're getting into our other known figures that use points and lines, but they're like line segments and rays. Those are defined because line segments we can measure. Rays, it starts at a point, and then it goes infinite, so therefore we can give it some kind of meaning. So consider the line AB. Remember, it's symbolized by AB with an arrow. We're going to look at just the line segment portion of it. So the line segment, or known as segment AB, notice the symbol, it's got a solid line now instead of the arrows, consists of the endpoints A and B. That means that I can actually take a ruler now and measure from A to B. I'm only looking from A to B. I'm not looking at anything past A or anything past B, just everything between A and B. Again, we still only name it by 2 letters. Now we can go backwards on this. We could call it BA, just like we could with a line, because it's passing through those 2 points, so it makes no difference which 2 letters, as long as you only name it by those 2. Now on the line, you can name it by any 2. Line segment, if you're talking about I want to just look at the portion of A to B, then you must use the endpoints. Okay, now array, notice its symbol. It has AB with the arrow on top. Now that arrow never changes. It always goes in that direction. What tells which direction I'm going is your initial point. Now in this case, the initial point is A because it's the end. Okay, and then it's passing through B. Now it could be any letter. You could have 3 or 4 letters on there, and you can pick whatever letter you want as long as you start with the initial and pick only one more. Rays are only doing by 2 also because again they're only one-dimensional, so they only have 2 letters. So our initial point in this case is A. We start with A when we read it, and because it's our end. Now remember, line AB can also be read as BA, and line segment AB can also be read as BA. However, array cannot, because now if we change it and we look at ray BA, notice the arrow symbol still on top, but the initial point now is B. That's telling me which direction it is. So those are not the same. Those are not the same. Ray AB and ray BA are different. Again, the arrow is still going the same direction, but it's saying I'm starting at B and going in a different direction. Now, opposite rays look like I'm looking at a line. And it is a line. Opposite rays are not anything else but a line. It forms a line, but it starts with the same initial point. So A is not my initial point. B is not my initial point, but C is. So I have a ray going CA, and I have a ray going CB. And since they form a line, they're known as opposite rays. Just like points, segments, and rays are collinear if they lie on the same plane, so any two opposite rays are collinear. As I said, they're on the same line. Segment rays and lines are coplanar if they also lie on the same plane. Okay, now, when we have lines and planes that touch each other, that's known as an intersection. Okay, so if they have if they have one or more points in common, then it's known as an intersection. The intersection of the figures is the set of points the figures have in common. Excuse me. About that. Oh, yeah, I actually went too far. You can tell it's time for me to go sleep. Late. Anyway, what I was going to say was you can tell that it is between. Right, segment addition postulate. This is the postulate that comes from what we just talked about. If B is between A and C, then you can take line segment AB plus BC to equal AC. I'm going to show a visual with it, make it a little easier to understand. So here's a line segment A, B, and C. Okay, they're collinear. B is between A and C. So what I can do is I can tell, okay, I'm going to take AB portion. I'm going to add on BC's portion. So they're connected. It's like connecting two line segments together. And when I connect them, it makes a longer line segment, AC. So that's all it is. Now we did some examples with this in class. Congruent segments. Congruent segments are when they have the same measure. Now, what they use to symbolize congruent segments is tick marks. As long as they have the same amount of tick marks. So notice DE has one single tick mark. FG has a single tick mark. If DE had two, then FG would have to have two if they're congruent. Otherwise, they don't have the same tick marks if they're not. Okay, so that's one way of showing it. These are called, oh, my highlighter keeps going off. These are called as congruent segments. Now, this is known as a congruent statement. We have to use the symbol on top of DE to represent it's a line segment, and also the symbol on top of FG. Now, the equal with the squiggly, that's known as congruent. Okay, that means they have the same measure. They're congruent to each other. And we're going to use that symbol whenever we ask you to write a statement or whenever you're doing proofs. It does mean, though, that DE is equal to FG. And notice I don't use the symbol because now what I'm doing, the equal represents measures, actual numbers. So I would substitute numbers in. So they're equal to each other. Now the segment bisector. Segment at its, you were going to fill in midpoint. So here is a visual that was hard to draw on the computer, so please understand that. But here's a plane N, and I have a line segment passing through the plane at a point, and that line segment is AB. It also is passing, oh, that points up. It's also, we have a line passing through, which is line RM passing through plane N, and it's passing, both of them are passing through at M. That black dot was supposed to be on M, the show up on my PowerPoint. That means, now please understand, we cannot sit there and say anything about the line. Okay, all we can say is it could be bisecting the line segment AB. But any ray, any line, or any line segment or plane can bisect the line segment. Only line segment. So we can say AM is congruent to MB. So here's another line segment passing through it, DM.